So in this question we're shown figure 8, and that's a sketch of the curve C with equation y is equal to x to the power of x, and we can see it is shown as a curve in the graph here. So in part A of this question, for 5 marks, we're asked to find, and initially we're told to take logarithms, the x coordinate of the turning point C. So we know that y is equal to x to the power of x, and we have to have a think. We're told we're to find the turning point. So when we have a think about turning points, the first thing that comes to mind when we want to find a turning point is finding the derivative and then setting it equal to 0. So that's going to be our kind of plan of attack here for this question. But first, like the question says, we're going to take logarithms of both sides. So we have y is equal to x to the power of x here, and then writing underneath we're going to now have ln of y is equal to ln of x to the power of x. And then we have our log laws, and what we know is that if we have ln of a to the power of m using the exponent log law, this will then be equal to m multiplied by ln of a. So this means we can use this log law to help us with this question, and we can rewrite this right hand side taking the exponent x in front of the log term. So we'll therefore have that ln of y is going to be equal to x multiplied by ln of x. And then what we can do now, we can differentiate both sides. So we know that ln y differentiates to 1 over y, so therefore we'll have 1 over y and then dy by dx. And then on this other side here, we're going to use the product rule to differentiate this. So product rule, if we have that h of x is equal to f of x multiplied by g of x, then we'll have that the derivative of h of x is going to be equal to f dash x multiplied by g of x, and then we add on f of x multiplied by the derivative of g. So in our case, we'll have x and we'll have ln of x, and we know that x will differentiate to give 1 and ln of x will differentiate to give 1 over x. So therefore, using the product rule, we can then use these values here where x is f of x and g of x is ln x, and substitute them into this product rule here, and this is going to give us our answer up here. So we will have x multiplied by 1 over x, and then we will then add ln x multiplied by 1. So tidying this up, we'll have that 1 over y dy by dx is going to be equal to x multiplied by 1 over x, so those x's cancel out, so that will be equal to 1, and then we will have plus 1 multiple of ln of x, which is ln of x. And then one thing that we have said at the start already, we want to set dy by dx equal to 0. So then setting dy by dx equal to 0, we'll have 1 over y multiplied by 0 is equal to 1 plus ln of x. And then we know when we multiply something by 0, it is just 0. So we'll then have that 0 is equal to 1 plus ln of x. And then we can rearrange this to have the ln of x is going to be equal to minus 1. And then now we can take exponentials of both sides. And we know that when we have the exponential and the log term, they'll cancel out, which leaves us with x is equal to e to the power of negative 1, which is the same as 1 over e, and that is also equal to 0.368 when we put that into our calculator and round to 3 decimal places. So in the question we were asked to find the x coordinate of the turning point of C, and we have found that here, and it is equal to 1 over e, which is approximately 0.368. So this question was worth 5 marks, and we receive our first mark for taking logarithms of both sides using the exponential log law to get to this stage here, where we had ln of y is equal to x multiplied by ln of x. We then received 2 marks for getting to the stage where we took the derivative of both sides, and that was saying that 1 over y multiplied by dy by dx is equal to 1 plus ln x. We then receive our 4th mark for manipulating this and setting it equal to 0 and getting to the stage where e ln of x is equal to e negative 1. And then we receive our 5th and final mark for coming to the correct conclusion and having the correct answer that x is equal to 0.368 or 1 over e. So in part B of this question, we're told that the point P, which has x coordinate alpha and y coordinate 2, lies at some point on the curve C. And we're asked to show that alpha, the x coordinate, is between 1.5 and 1.6. So first of all, we recall that the formula for a curve C is y is equal to x to the power of x. So what we're going to do is we're going to take these two values, 1.5 and 1.6, and substitute them into our equation for y. So for x equal to 1.5, we'll have that y is equal to 1.5 to the power of 1.5. And putting this into our calculator and rounding to 3 significant figures, this comes out as 1.84. And then likewise for x equal to 1.6, we have that y is equal to 1.6 to the power of 1.6. And this comes out as 2.12. So for the point P, which has coordinates alpha 2, we have that our y values when x is equal to 1.5 and 1.6 are 1.84, which is less than 2, and we have that 2.12, so our y value when x is 1.6 is going to be greater than 2. So we have that 1.84 is less than 2, and then we have that 2.12 is greater than 2. And we also know that C is a continuous curve. Hence, for these reasons, we can conclude that alpha is going to lie between 1.5 and 1.6, which is what the question asks us for. So there was 2 marks available in this question, and we receive our initial mark for substituting in both our values 1.5 and 1.6 into our formula and coming out with 1.84 and 2.12, and we then receive our second mark for stating this bit here about the y values being below and above 2, and then having a concluding statement and concluding the correct required form of alpha is between 1.5 and 1.6. So in this part of the question, we're given some further information, and we're told that a possible iteration formula that could be used in an attempt to find alpha is going to be x n plus 1 is going to be equal to 2 of xn to the power of 1 minus xn. And we're told that we have an initial x1, which is equal to 1.5, and we're to use this formula to work out what x of 4 is to 3 decimal places. And we begin by taking our formula, and we can work out that x of 2 is going to be equal to 2 multiplied by x of 1 to the power of 1 minus x1, which is going to be equal to 2 multiplied by 1.5, and then that is going to be to the power of 1, take away 1.5. So we put this into our calculator, and this comes out as a number with lots of decimal places, and it goes like this: 1.63299 and so on. So then what we can do next is we know that x3 is going to be 2 multiplied by x2 to the power of 1 minus x2. So then rather than taking our value for x2 here, which if we were to round to say 3 decimal places would give us an inaccurate answer going forward, what we can do in our calculator is initially we will have put 2 multiplied by 1.5, but what we can do is we can use the answer button as our calculator stores this answer, and then this means that the calculator will use the full value of this for x2, and then if we do this once, this comes out as 1.46626 and so on. And we can then just press the answer button once more, which will give us the value of x4. So the formula stays the same, and then this comes out as 1.6731 and so on, and we're asked to work out x4 to 3 decimal places. So then we round this to 3 decimal places, which comes out as 1.673, and therefore we've answered the question. This question was worth 2 marks, and we receive our first mark for getting to this stage here where we've calculated x2. So this is when we've used our initial value x1 and substituted it into the iteration formula that we're given, and then we receive the second mark for following through with these other values and concluding that x4 is equal to 1.673. So in part D of this question, we're asked to describe the long-term behaviour of xn. So as n tends to infinity, what happens to the value of xn? So that's what the question's asking us. And what we can do is if we continue pressing the answer button on our calculator like we did to find x4 in part C of the question, we'll see that firstly, the value of x of n will stabilise and it will begin to fluctuate between the value of 1 and 2. So this means that it will be 1, then 2, then 1, and then 2, and so on. And this pattern will continue. And this also tells us that the behaviour of xn will be periodic. So we'll have the xn will be periodic. And we have to think, what will the period be? So the period will be 2 because of the way it's oscillating. So with period 2. So this question was worth 2 marks, and we receive 1 mark for each statement we make here, which is about the periodicness and the fluctuation of x of n as n gets large.